So here in example B, we're going to use law of cosines again, and I'm going to write the relevant equation. So c squared is equal to a squared plus b squared minus 2ab times cosine of capital C. And I particularly chose this one because we're trying to solve for the longest or largest angle, and that's going to be associated with the biggest side length. So I chose C, and now I'm going to manipulate this equation algebraically. So I'm going to add 2ab cosine of C to both sides, and also subtract C squared from both sides. So that's going to give us 2ab cosine of capital C is equal to a squared plus b squared minus c squared. And then I can divide both sides by 2 times ab. And then I can apply cosine inverse on both sides. Okay, so I've manipulated that equation algebraically, and now I can go ahead and plug in the values that we have highlighted here, and we find that C is equal to cosine inverse of 9.47 squared plus 15.9 squared minus 21.1 squared over 2 times 9.47 times 15.9. That's a lot to plug into our calculator. Okay, so we're going to do cosine inverse of 9.47 squared plus 15.9 squared minus 21.1 squared divided by 2 times 9.47 times 15.9. Okay, so I went and did something incorrectly. I think I need another parenthesis here. Nope, that's not it. Okay, maybe let's break this into parts because clearly I'm on the struggle bus. So let's do 9.47 squared plus 15.9 squared minus 21.1 squared. Okay, so I'm going to store that as capital A, and then I'll calculate the denominator. So 2 times 9.47 times 15.9. I'm going to store that as capital B. Okay, and so now we are doing cosine inverse of A divided by B. Awesome. Okay, that gives me the number that I want. So 109.9. Okay, from here, we can use law of sines to figure out the second angle, and then the third angle we can use adding up the other two angles and then subtracting that from 180. Since we've done a few of these examples now, I'm going to go ahead and leave it up to you to solve for angles B and angles A.